It's exciting times in Apache CloudStack, right? We heard IOTA is building multiple hyperscale clouds with using CloudStack, and Rohit mentioned about the number of users in CloudStack community has increased a lot. While we like to believe and understand, rightly that CloudStack is comparatively uh, easy, looking at the competition. Uh, but the product itself, the technology is complex. We cannot deny that. For the new users, I believe there is still a learning curve, and they might find sometimes challenging to build the cloud on their own. We have a lot of documentation, guides, a lot of articles about building cloud with CloudStack. But there is always a challenge, and as a community, we all create some content guides and from our experience in sharing our knowledge with the wider community for the new users so that they might find it easy to use CloudStack. So I would like to make an attempt to share some knowledge in helping the new users deploy their cloud, a cloud IaaS cloud with CloudStack easily. And I have been helping users of CloudStack in different countries deploy clouds with in different scale, different sizes for many years. I have been helping users use CloudStack, fix their issues, provide consultancy, help with upgrades, and design and deploy CloudStack as well. I'm a committer in the Apache CloudStack community, and also a cloud architect at ShapeBlue. At ShapeBlue, we provide engineering services, consultancy, support, training for CloudStack, and we recently launched a certification for Apache CloudStack. You can take a look at that in our website for more details. And these are some of the logos you might find familiar, of course, and these are the organizations we work with. Before I give you some idea of how to design and deploy CloudStack, I would like to give you a short demo of CloudStack. Whether you are a root admin or a normal user using CloudStack, many of the use cases, user experience would be similar. I would like to show you the user experience of a normal user using CloudStack. A normal user can use UI, CloudStack UI, the CloudMonkey CLI or API. You may have end user portals as well on top of CloudStack. But using the UI is a common scenario. The user logged in and the user is in the CloudStack dashboard. As you can see, this is what users can do with CloudStack. This is what they have access to, their compute, storage, and so on. And we have the dashboard here with multiple cards here. You can see 5 cards here. And these cards shows what the account of the user have access to, a quick summary of their account. So on the left top, we have resources, which shows a summary of the resources that this account has deployed, including instances, volume, Kubernetes clusters, and so on. And we have infrastructure categorized into compute, storage, and network with limit and the current consumption showing for different resources under the same group. Also, we have a card with events that is related to the most recent events for this account. A typical user, when they log in, as you can see, this user has logged in before, created resources. So they may operate on the existing resources, like perform lifecycle operations, or they may even want to create something new. Let's see how they'll create something new here. The easy way, the one that I like is this quick create button, where you can easily create new resources. What you can do with that is you can create instances, Kubernetes clusters, volume, network, VPC, template, and even deploy VNF appliance. Let's see the typical scenario where user deploys an instance. Like in many cloud solutions, first you need to select an availability zone here. Let's see what I have got here. I have multiple availability zones here. That includes advanced zones and even core and edge zones. So I would like to use this Sophia zone. And as you can see here, I need to make further selections. And whatever I select here will be shown in the summary here. Okay. And I can deploy the instance from a template or an ISO. Let's see, I'm using this Alma Linux KVM template. I've got multiple hypervisor types in this one, so I see multiple options there. Then I need a compute offering which has defined virtual machine specification for me here. I would like to use this medium instance which has got one CPU and 1 GB RAM. That's fine for me. And let's see. I can also attach another disk, data disk. So let me use this 100 GB disk. What else I need to do? I need to attach this instance to a network. I'm using this VPC tier. I would like this to be deployed along with in a VPC. Probably I will select L2 network as well. Okay, this place. Okay, I'll skip that. So I have selected this network, and I can make some more selections in the advanced mode, boot type, and so on. I'll put in some name for it. This will be also going to the host name and the FQDN of the instance, and all the details of the instance configuration I have selected is here, and I can launch the instance. I can also launch and wait here and continue with another instance, making some changes to the instance name. Okay, I have hit some error due to, but you get the point. I can deploy the instance. Is due to the resource limit. That's fine. So I have deployed some instance. So I have some instance deployed earlier here. So let's take a look at one of that instance and see what we can see here. We have the details of all the instances, all the details of the instance here, including the OS type, the CPU and memory configurations. I have other properties of the instance detailed here. Along with that, I have some metrics of the instance collected from the hypervisor. I can see that for last hour, 24 hours, and so on. I can also take a look at the volumes of this instance. We have got two volumes, root and data. If I want, I can also create another one and select an appropriate disk offering and attach that right here. And what is the network for this instance like? It is attached to an L2 network in this one. I don't have any instance snapshot, but I can create one. I can also create schedules on this instance, which is like cron jobs, where you can probably you may want to start the instance, stop the instance in the night, late, and probably start in the morning. So all these are some possibilities you can do with schedules. If the instance is stopped, I can configure the instance settings that are specific to this instance. And if there are any events associated with this instance, I can see that here. What else I can do? I can view the console, copy the console URL, edit the instance, and then I can stop the instance if I need to, reboot it, reinstall from the template if the instance has some issue. Probably I want to go back to the template state. I can do that. I can create instance snapshot from right here and attach an ISO. Also destroy the instance if I don't I don't need this instance any longer. I don't have to go to the hypervisor management platform or anything for it. All the users have the self-service capability to deploy their instances and manage them. I can also create Kubernetes clusters where I can run container applications. The cloud admin has created and uploaded some Kubernetes releases here. I can use one of them and select an appropriate offering and deploy a Kubernetes cluster. So I have created something here already. So using this access, I can configure my kubectl and access the Kubernetes cluster and configure it. There is some load balancing rule which CloudStack creates for you. Also some port forwarding rules. Rest of it depending on your Kubernetes configuration, it will be applied on the CloudStack. I can create volumes from here as well. I can also go to volumes and see if it has got any volume snapshots. I don't have any, but if I want to, I can go to some same instance. I can create a manual snapshot, a volume snapshot here. It will create a volume snapshot in the secondary storage of the zone. I can also select a remote zone where it will copy the snapshot to a remote zone if required. Like in case there is some issue with the original zone, I can deploy the instance there in the remote location later on. I can also create schedules for the volume snapshot. I don't have to do this manually all the time. I can create some schedule like hourly, daily, or weekly, or monthly, and select an appropriate time in which at which you want this volume snapshot to be created, and probably mention a retention, mention the number of snapshot you want to retain, and select the time zone in which you want this to perform the snapshot. Snapshot creation and copy operation. Here also you get one more option where you can select a remote zone where it will be copied to. Here are some networks created by either by this account or by the root admin, which is accessible to this account. This user can create isolated network and L2, and also there's a possibility of creating shared networks in some specific scenarios. The user can also create a VPC, and there is some VPC already created. And also, user can deploy VNF appliances and create side-to-side VPN for VPC. I have some template here. I can also access the templates that are made available to me by the cloud admin. If I want, I can register my own template either by registering the URL from a web server or upload from the local. Similarly, you can upload ISO or register ISO as well. Another option is to now all the resources I create belongs to the account. Another way would be to collaborate with other accounts and users in the same domain. For that, we have projects in CloudStack. You can create a project and add other users and accounts in the same domain, and they can work collaboratively. All the resources created by within the project will belong to that project. I can switch the project, and it will change the dashboard and all the details of all the resources to specific to that project. Now you see a different resource summary, right? Irrespective of whether you are deploying an instance or Kubernetes cluster, you may want to create some object storage. So using Minayo, there is some integration we have created in this setup where you can create a bucket and upload your data and access it. Now you have some idea what a user can get from CloudStack, or what you can provide to the end user using CloudStack. Let's see how you build or some service like this and provide a similar service to end users. This is an example of a typical installation or deployment using CloudStack, where you first design and look at your physical infrastructure, look at your logical layout, and look at your requirements that you need for deploying a CloudStack. And there are a lot of steps that are coming in the pre-installation, installation, and post-installation steps of the your IaaS cloud deployment. So where do you start? You start with laying foundation for the data center. Not really. Maybe you can deploy CloudStack using, with very large data centers like this one, your top, or even you can deploy in your home with any hardware that you have. There are many scale that you can reach with CloudStack. You can start with very small, simple, single server, and even you can go to very large scales. It's totally up to you. But in general, I would like to represent a typical CloudStack infrastructure using this diagram, where there is a layer 3 switch and firewall, and you have your physical networking infrastructure. This is a simplified diagram, of course, and you have management servers and the database for running the CloudStack, and load balancers. Of course, we have a cluster of management servers. You need secondary storage, you need some compute, and you have storages for your virtual machines. So how these are interconnected? You need to have some connectivity between your management servers, host, and the storage from the KVM host. And for secondary storage, you need to access them from KVM host as well as from the management servers. And your virtual machine needs to be connected to a network. It needs to be isolated using different traffic. And these virtual machines need to access external network. You need to access them from external network, probably from intranet or from internet as well, depending on completely on your use case. So we have some connectivity that is required for that as well. So where do you deploy it? Typically, I find it easy when you deploy management servers and database servers in virtual machines. It doesn't really matter what hypervisor you are using. Of course, these are not managed by CloudStack itself. You can deploy, probably get new servers and deploy these as virtual machines. Or probably if you have some existing virtualization environment, you can deploy them as well. A typical installation would be with 4 virtual machines with 2 management servers and 2 database servers, 1 master and 1 slave, and the configuration with 8 vCPU, memory of 16 GB RAM, and storage depending on whether it's management server or database server. You can go with either 10 or 500 GB. You should be able to manage up to 1,000 hosts with that. If you want to manage more, you can scale out or increase the specification of these servers. You could go with some low-end servers for running the management servers. It is always advised to keep it different from the compute. You don't really need to have high-end servers for running this. These do not really require a lot of resources. You could run them on existing your management hypervisor cluster as well. Just 2 of them so that you deploy in 2 different servers. And the hardware or make of the model server doesn't really matter. Mostly it has been x86, but there is support for ARM as well here. So the typical installation is with x86, so that's the reason I have given that. You can either run these management VMs on the local storage, or you can use shared storage as well. And you need to have some good connectivity. A lot of bandwidth is not required, just that it needs to talk to the management infrastructure and secondary storage sometimes. Just it needs to have the route to it. To decide further what hardware and how you build your CloudStack, we need to identify some scale. So in this case, I have identified or simplified example with an average instance specification of 2 vCPUs, 8 GB RAM, volume of 550 GB and 100 MPS bandwidth. With this, I'm expecting to deploy 500 instances with medium density allocation on medium and compute nodes. So I'm going with 8 hosts where I have 7+1 redundancy. Here again, the server model doesn't really matter. I'm going with the CPU specification, RAM specification as shown here. Although I can deploy the virtual machines onto the local storage on this one, I prefer to run it on a shared storage for HA and availability reasons. NICs can be 10, 25 gigs depending on your use case. Since I'm using a shared storage, I need about 20 TB of NFS. I'm trying to keep it simple with NFS, but again, what storage you're buying doesn't really matter. And for secondary storage, this example is primarily with KVM, so I'm expecting volume snapshot to be taken, which are full snapshots. So expecting is 10 TB of storage. You don't really have to go with in the beginning. You can always add later on. And you need a lot of networking hardware, of course. I'm just giving some example of the switches that you need with this network diagram I have shown here. You have all the hardware required. Can we start deploying a CloudStack? Not really. You need to have it connected and provision your network and VLANs, depending on, again, what isolation method you are using. Typical CloudStack installation preferred, will be mostly with VLAN. So I'm using that as an example. We need different network requirements for deploying a CloudStack, just one zone, right? In this case, I've taken 200 public IPs as an example. I'm expecting 500 instances across 100 users, like average 5 instances per user. So I can start with 200. It should be okay. Later, if required, I can always increase the range or add more networks to it. That's not a problem. I can add more VLANs as well. I believe I can start with 200 VLANs. That should be okay. Later, if required, based on the demand, I can increase the number of VLANs. I'm not using a separate storage network for the secondary storage. I'm good to use management network for the storage itself as well. And I need to reserve some IP address for the public IPs and management IPs for the system VMs. If you are using VMware, you need to reserve more IP address for the management network. And the management server hypervisor need to be configured to make sure the virtual machine can access the management network. And if you are using a dedicated storage network for secondary storage access, you need to make sure that is also possible. Coming to your compute host networking, I will not be using a dedicated storage network for the secondary storage access, but you can create a bond with 2 NICs and run management as well as your storage on them. And the other 2, I'm running guest and public. So with this, you can build your cluster. This is just a now simplified example. Just take this as a reference, not really go by the numbers. So are you ready to really deploy CloudStack? Probably, but there could be some information you might find useful to deploy the CloudStack, such as what here. You have deployed a CloudStack, and what do it really contain? So all these infrastructures are mapped to something in CloudStack. So your typical installation of a single CloudStack, with management server clusters and database would be called as a region in CloudStack. And within that region, you can have multiple zones. A zone could have a single data center, multiple, or you can even have multiple data centers in a zone. It's completely up to you. In this example, I'm just going with one zone here, and I'll have one port. I have 8 hosts, and I will probably keep them in a single cluster. And I have my host here, right? And this primary storage, I prefer to keep it in the zone level, but you can have it in the cluster level as well. And of course, local storage is supported. Later on, for expansion, I can add another zone. Again, this physical infrastructure view of the typical CloudStack installation. And for compute, also I said the example is with KVM. You have multiple options here. You can use KVM, you can use VMware, you can use SenServer and XCP-ng. While Hyper-V and OVM are not really maintained anymore, those are also some existing integration. And Hyper-V, I believe Hari and Abhishek are giving some talks later on, which probably will give you some idea what is the future of that. And bare metal, again, I believe there should be some option in the future releases where we can use bare metal. Right now, it's not properly maintained. I need some primary storage for my virtual machines, right? Here we have the usual suspects. I prefer to use NFS to keep it simple, but there are other options with local storage, I2C, and fiber channels. So if you are not happy with this, you need other options. Along with this one, you can have other options, and there are multiple options available where you have managed storage as well. You have Ceph, Linbit, where Mr. will be giving a talk on Linbit later on. You have multiple integrations from NetApp, Dell, Storepool, Pure Storage, and SP. What else you need? You need a secondary storage. People who come from typical virtualization background, they forget about secondary storage, I see a couple of times. Then we are at the end of the design, we realize, okay, they didn't buy hardware for secondary storage. Then they'll quickly, spin up something and then do it. So don't forget about secondary storage, where you will keep the templates and ISOs. The options here are NFS. NFS is the default choice. There is integration with S3 and Swift, but again, these are not very well maintained. And you have the latest here, that is object storage support with CloudStack. You can provide your users object storage access through CloudStack. The existing integrations are Minayo and Ceph, but there are other integrations I know which are coming up soon. Coming to networking, you have two styles: advanced and basic. The advanced one is what people mostly use, where your isolation methods are by default, or the common isolation method is VLAN. And with KVM, you can also use VXLAN, either with multi-class group or EVPN and BGP. And there is an XS integration if you are using VMware. And there are other options like Tungsten Fabric and few other, which are not really production grade at the moment. And there is option for basic zone, which has got a layer 3 isolation mechanism using security groups. Security groups are nothing but host-based firewalls implemented using IP tables, EV tables, and so on. What else you have in networking? We have a big list of services that CloudStack provides in networking for the users. And this, I can start from static routing, DHCP, DNS, dynamic routing, redundancy using BRRP, password services, NAT, that includes both source NAT and static NAT, load balancing, VPN, that includes remote access VPN and side-to-side VPN, port forwarding, firewall, user data, metadata, and so on. So all these services by default are provided by the virtual router in CloudStack. So CloudStack has this concept of system VMs, which are created using system VM templates, which are basically Debian-based appliance, which are secured, hardened, and minimal, having a minimal footprint, essentially just to have the CloudStack network services and other services running. These are virtual machines running in your infrastructure, the same compute infrastructure. So if you look at this, your typical network with isolated network, where virtual router is in the data path, which where it is the default gateway. Your virtual machine traffic passes through the virtual router, and there are multiple services. For example, the packet forwarding, everything is essentially Linux kernel functions, and dynamic routing is implemented using FRR. DNS and DHCP are implemented using open source components like DNS mask, and keep alive D and contract is used for implementing the redundancy functions. And we use Apache service for metadata and user data services, and there are static routing policies that are implemented using IP route 2. HA proxy, of course, provides the load balancing services. And there are custom scripts that are created by the community, which provide services like the password services monitoring. And we need some, something to get the network usage data. So all these are what virtual router provides. There are other options as well along with virtual router, but of course, virtual router is the default choice. And another system VM is console proxy virtual machine, CPVM, which essentially has the functionality of relaying the virtual machine console from the hypervisor to the user, irrespective of the hypervisor type that you are using. A user typically connects to the console proxy, console proxy VM, where they actually get the console from the hypervisor. The user doesn't really connect to the hypervisor directly. And we have secondary storage VM. which essentially takes care of every operation that is related to the secondary storage, like uploading the template, downloading the template, ISO, managing it, creating templates from snapshots. If you are using VMware, it is also involved in deploying the instance where it copies the data from the secondary storage to the ESXi host. Also, it takes care of backing up to the secondary storage for the volume snapshots. What else do we have in CloudStack? You need to know that there are templates. We saw that in the demo. There are templates and ISOs. It supports everything that your hypervisor supports. And you can use all varieties of templates, whether you create outside CloudStack using tools or directly on hypervisor, or you deploy from ISO and create a template from the root disk of the instance. And ISOs you can register or get from distributions and so on. And of course, you can manage the lifecycle of your instances using CloudStack. You don't really need to, the user doesn't really need any access to the hypervisor management or anything at all. So several OS types are supported. It provides a very rich list of orchestration operation options. For instance, if you look at the API reference guide for CloudStack for the virtual machine, starting with deploying virtual machine, that's the biggest list possibly of the APIs that are there for the category of instances. So that's the biggest list, I believe, and you can do pretty much everything, for starting, stopping, creating snapshots, and so on. Of course, with instances, you have volumes. So irrespective of your hypervisor type or storage type, CloudStack manages the volumes for you. That are root volume, where your operating system data resides, and data volume, where you typically keep your data, right? And once you create the volume, depending on where the instance is deployed, CloudStack abstract the details of how it's created and everything. It takes care of provisioning it, either using managed storage or directly talking to the hypervisor. And it'll take care of all the formats and implementation of all the properties of the volumes in the infrastructure. What else do we have? We have got two types of snapshot that are possible with CloudStack. Of course, there is VM snapshot, instance snapshot, which are hypervisor snapshot that you can create and manage using CloudStack. Also, there is volume snapshot, where you create a snapshot of the volumes using CloudStack. These are typically backed up to secondary storage, which you can use it sort of as a backup as well. And later, if you require, you can create templates or new volumes from the volume snapshots. What else we have? We have backups in CloudStack. Backups in CloudStack are provided through the backup and recovery framework. The backup and recovery framework abstracts the complexities in the backup providers and gives you a seamless experience like it does for any other integration. It is agnostic to the provider, like we do with hypervisors and so on. So users can use the CloudStack API and UI and create their backups. Currently, there is a NAS backup plugin using which you can simply use your NFS storage for backups for KVM. And there is Backroll integration for KVM that is in progress. And there is VM integration for VMware. And there is Dell Networker integration that is for KVM again. Using backup, you can restore the instance, restore just a volume attached to another instance using which you can restore. And there is an upcoming feature to create instance from backups later on if you do not have the instances. So all these resources that we just saw needs to be defined in some form in CloudStack. So the way you sell your CloudStack are based on what you define, such as service offerings, which defines products in CloudStack which you sell to end user or provide end users, right? There are different types of service offerings, starting with compute service offering, disk offering, network offerings, backup offering, VPC, and there is a system offering just for the system VMs. So what does it contain? So if you saw me in the demo, there are multiple offerings defined, right? So these offerings define the characteristics of the instance, like CPUs, memory, root disk properties, whether it's thin provision, there is network throttling in that. You can control using tags where this needs to be placed and so on. So a whole lot of list of properties that you can define on the compute offerings. And disk offerings, it basically is for either if you're creating an instance from an ISO, then this buffering needs to be used for creating the root disk. Otherwise, it's used for creating the data disk. This specifically contains specifications that you need for the disk, such as whether you are thin provisioning it or thick provisioning it, whether you want to deploy it, and the size of whether you want to make it custom, the size, and so on. And there is a system offering for similarly to compute offering, where you can define the specification for your virtual routers, SSVM and console proxy VM. Typically, in large deployments, the default configuration for the virtual router may not be sufficient. You typically increase the size depending on the use case, right? There may be VPCs having multiple VPN connections and thousands of access control lists, and they may send a lot of traffic to the virtual router, so you need a bigger offering. So what else you need to know about CloudStack? So CloudStack has got different network it manages. All these networks in CloudStack, virtual networks in CloudStack, has categorized into different types, traffic types essentially. The public, of course, where the users connect to your workload. That's our public. This can be actually internet routable public IP address or intranet if you have that use case. It's completely up to your use case. And the management, as the name says, everything that all the networks that connects the control plane, that is the management. And the users all the user networks are categorized into guest networks, and storage is not the primary storage network. Please mind that it's just the secondary storage. So primary storage you need to define separately. Just make sure whatever you're using, IP or whatever, FC, whatever, you just need to make sure the host hypervisors can access the primary storage. CloudStack did not really take care of that. And the storage network in CloudStack is optional, by the way. And in the guest network, we have multiple options again. So we have isolated, which is common, where the virtual router is in the data path, typically source netted, but you can do static and dynamic routing as well, where it provides multiple services, forwards your data, which is it is also the default gateway, and your layer 3 gateway is a hop later on, right? And that is shared network. Suppose you don't want to use the virtual router in the data path, but still you want the network services provided by CloudStack, such as user data, DNS, DHCP, and so on. So this is your shared network for you. This can also be shared among other multiple users, and that's what we have in CloudStack. Your instances directly, their gateway is your L3 gateway in your data center, and virtual routers not in the data path. Suppose you do not need all that. You don't want the virtual router to take care of the network services in the CloudStack. Then you have L2 network, guest network offering. You can still provide the network services through externally, but you want CloudStack to manage the instance provisioning in the network segment. If you, suppose if you want a richer network topology, we have VPCs where you can create multiple subnets attached to a virtual router, and the inter-VLAN routing is taken care by the virtual router. And there is access control list using which you can control the traffic in and out of the tiers. And it provides multiple options in a networking in your VPC, where it gives you an option to create side-to-side VPN to your remote data centers, even another VPC. Also, we just got remote access VPN, and you can use private gateway and connect to either, again, remote data centers, another VPC, or some physical equipments in your data center or premise. And you can send the traffic over the L3 gateway, and the rest of the transport you can figure out, probably using any transport technology. And this is VPC for you, right? What else we have got? CloudStack is about the multi-tenancy and the self-service of the resources, right? So everybody wants a cloud consumption model. So it has got multiple resources of different users and different tenants. So CloudStack has a way of organizing them in accounts, domains, and projects for you. So let's see a typical user like the one we saw in the demo. A user in an account has created a network and an instance here that belongs to a subdomain, a customer's domain. And the other option is user can create a project and create a network, and multiple accounts or users can be added to this project from the same domain of this customer. And that is one way of organizing the users. And the subdomain, the customer's domain, belongs to the root domain, which is a parent, and the default admin account, which is a root admin, of the root admin role, of course, in that domain. And even the admin can create the resources, right? And you can also have domain admin, which can manage the domains. So you have all these resources created by users in the CloudStack. So how do you sell it? Right, you need to meter it. So CloudStack provides usage service which can track all the resources. Identify different resource type, track them separately, and give you a detailed report of what's happening with respect to the usage of the resource in your infrastructure, so that you can either use it for billing or for audit purpose if you are a private cloud where probably billing is not a use case. So this is what enables the billing on top of CloudStack, and it gives you resources for instances, whether it's stopped or running separately, metrics of usage for volumes, templates, and how much storage they have occupied, so that you can build them. And that's not all. You have several resources which we already covered here already, hypervisors, storage, and so on. And there are multiple possibilities that are on top of CloudStack, where CloudStack acts as a platform. You can have a lot of integrations on top of CloudStack automations you can create. There are different integrations that are already there, and many are possible with CloudStack. And this is how you will probably creating CloudStack. I believe using these resources, you have a better confidence in deploying CloudStack, and you can take a look at different resources that are available. You can reach out to community. The community is really helpful. If you come across any issue, you should be able to deploy your CloudStack with better confidence. There is some video from Sheblu in the Sheblu YouTube channel. You can take a look at that. I'll skip that for now. So that's all. I believe you should be able to deploy your CloudStack with better confidence now. I know it was quick and really fast, but and there is much more, but we cannot really cover all of that today, right?
Questions? So in my data center, if I'm running a one big self cluster, can the primary storage and secondary storage be from the same cluster?
Primary storage, you can make it available to the entire zone. If you have single cluster, that cluster will use. Later on, if you add another cluster, then that cluster also can use, right?
So my question is, can one single self cluster?
Self cluster, okay.
Self cluster. Because I'm a very big self cluster in my data center. So can the primary storage and secondary storage be the same cluster?
People do that. With Ceph, I mean, I believe you don't really worry, but if it's something else, probably I would recommend separating it.
Yeah, because Ceph is a high
in case of Ceph, it's your confidence. Yeah. Yeah. But otherwise, it's recommended to separate them.
I have one more question. Any plans of adding platform as a service or database as a service in the community? I mean, is there work going on?
We don't have anything. In the last CC, there was some talk given by someone, but you can find more details on it. But we are not sure. Yeah, yeah.
Thank you.
Yeah, I can hear you.
Okay, so in our cluster, we are using a storage. Okay. So if my KVM host goes down, it is blocking that NFS. I cannot bring my VM up. So now we are using NFS with more of a VM. So is it right configuration or do you use this?
You are using NFS as a primary storage. And when the host goes down, you're unable to bring up the virtual machine and the host because of the logs. Yeah, I think we have seen that. I don't remember what exactly was the cause of it. I can probably connect with you later on. I've seen that, but I don't recall. Yeah.
Okay. So right now we are
probably with the version.
It resolved the issue, but no longer is not recommended. Because it can cut back.
I didn't hear that. Sorry.
I'm saying right now we are using no log option and mounting another
Oh.
storage. So it resolve issue,
Mm.
but no log option is not recommended.
Okay. Yeah. Yeah, I don't recall what was the solution for it, but there was some workaround, I believe. Yeah.
Hello, so my name is Gaurav. So now we are using Apache CloudStack on a large scale, but our main area is the backup. So any plan of integrating enterprise products like Rubrik or something with the backup? Because we know there are many solutions we can directly integrate with the KVM, but not with the Apache CloudStack. So
Yeah.
that's a pain area for us.
Yeah, so what is there is the backup and recovery framework, which enables anybody to create plugins for any vendor of your choice. We have our own preference when it comes to what backup solution we would like to use. Probably the relationship with the vendor or what we have used to, or various reasons. So CloudStack has some options right now, which is Veeam for VMware. If you are using KVM, we have NAS backup, which is essentially using your NFS share. With KVM, I don't know what is in the roadmap for backups, to be sure. Yeah.
Even I was evaluating Backroll, but Backroll is not fully released yet. This Apache CloudStack.
Yeah.
It's not in the options what we are trying.
Yeah, right now the PR has not merged yet. Probably, soon we will have it merged.
You also mentioned about backup manager. So, is it currently available or is still in development?
Yeah, backup and recovery in CloudStack was available since 4.14 or 4.15, only with Veeam then, with VMware. With 4.20, we have NAS plugin. Uh, Network was integrated some time ago, Dell Networker. So if you're using the latest version, we have these options: NAS backup plugin for KVM and Networker. Uh, the back roll should be available soon, for production. The plugin PR is submitted but not merged yet.
You are expecting for backhoe. Okay, and another thing is you also mentioned about the snapshots, native snapshots. So what we have noticed here, normally when we take native snapshot from CloudStack, it twice the region in the backend and it goes to the non-responding state for maybe certain uh, 1 minute or 20, 30, 40 seconds. So, which is not ideal for production. Yeah. So, is it still recommended or because with VMware we don't see any such issues? Yeah.
Yeah, I'm aware there was an issue, but with KVM, uh, I don't know whether CloudStack can solve that, or maybe probably we'll have to see what could be done differently to do that. I don't know if it's still is it still present. Which version you're using?
So, 4.19.
Okay.
And that's the problem with KVM also, I think. Yeah, because if you do directly with the KVM, you get the snapshot and
Yeah. If you have a way to fix that in KVM, then of course that's solved for you using CloudStack, right?
Okay.
Hello, my name is no, my name is Abhishek. So we are using MariaDB as a storage engine. So what would you backup and storage? So what would you recommend? Like when we are using the SQL, so job got stuck, and we need to into the database and we need to kill the job. Like if we are deleting a VM or we are installing a VM.
You're using MariaDB as a
Yeah.
backup database for CloudStack.
Database.
CloudStack.
Yeah.
And issue you're facing, I didn't quite catch that.
When we were using the MySQL database and for the backup, at that time it got stuck.
So, what it refers like initially we faced issues like if we are doing some VM moving VM from one host to another, then the volume states were going into always into migrating state and we were not able to recover. So I think that was later with version upgrade it was fixed. Yes, there was a bug, right? Yeah. Yeah, it always goes to, and then you have to do cleanup from the database side. Otherwise, your things will always be in the migrated state.
Yeah, it's good to avoid modifying the database, by the way.
Oh yeah, we did it in some POCs in pre-production, but yeah, in production.
Yeah, probably in the older versions, it was using secondary storage for migration. Depending on the size of the disk and network, it may take longer, but I think it's fixed now.